So visible, it's visible. Is it visible?
Yes.
Sir, yes.
Yes, sir.
Okay, so that's what we were discussing last day, the mapping between S plane and Z plane. So we know that the j omega axis in the S plane, it will map onto the circumference of a circle of radius 1 centered at the origin in the Z plane. All right. The left half of the S plane will map into the interior, the inside of this circle. And the right half of the S plane will map into the outside or exterior of this circle. So that was the overall thing that we observed. But there are finer details that we want to explore now. Point is, if you sweep along the j omega axis, then in what manner will this traversal take place? So do that. I have just given this figure first. All right. So this is the S plane. Suppose we start from the origin here. So at the origin, omega is 0. Sigma obviously is 0 because we are traveling along the j omega axis, and omega is also 0. When omega is 0, what will be the argument of Z? What will be the argument of Z? Remember that the magnitude of Z is e to the power sigma tau, and the argument of Z is omega tau. So here omega is 0 means omega tau is 0. So corresponding to that point, we are sitting here on the circumference of the unit circle centered at origin in the Z plane. Here along the real axis, it's unit distance away. So that is the image of that point, the origin in the S plane. Because corresponding to the origin in the S plane, the Z will be 1 with argument 0. All right. So this is the location. Now suppose you are traveling upward. Then what will happen? In what manner will the traversal take place along the circumference of this unit circle in the Z plane? As you travel from the origin upward, what will happen? Value of omega will increase. Because you are along the j omega axis, magnitude of Z will always be 1. It's e to the power sigma tau. Sigma is 0. So when you are traveling upward, what will change? Simply the argument will change. Therefore, because the argument will change, if you draw this a straight line here representing Z, this is the argument. All right, this is the argument. So as you increase the value of omega, it will travel in this direction. What will happen as you reach this point, j omega equal to j omega is by 2? What will happen there? As you reach this point, j omega is by 2. Where will you reach along the circumference of the unit circle? Magnitude of Z will be 1, so you will be remain along the circumference, and argument will be omega is tau by 2. Omega is tau by 2 means pi radians. All right. So you will reach here. As you reach there, j omega is by 2. This is the point where will you reach. So you have just traversed a semicircle. As you move further upward, what else will happen? What will happen now? Omega will increase further. So you will be traveling in this direction. What will be omega? Omega will be this angle. So you'll be traveling in this direction. In this way, you will continue until you reach that point j omega is. Corresponding to j omega is, what's the argument of Z? Omega is tau. That means 2 pi radians. So you will come back here. All right. As you travel from omega equal to 0 to omega equal to omega s, you will make a complete traversal of the circumference of this circle centered at origin in the z plane with unit radius. Now, if you continue to travel upward, what will happen? You have come back here. As you have reached the point j omega s, if you continue to travel upward, again you will travel in this direction because argument will go on increasing. And when you reach when you reach j omega s by 3j omega s by 2, you will come here. All right. As you proceed further, you will again travel in this direction, and ultimately when you reach j equal to twice omega s, you will come here. It implies this situation will continue. It implies that this point on the z plane, unit distance away along the real axis from the origin, this is the image of omega equal to 0 plus minus n omega s, where n is equal to 1, 2, 3. Starting from origin, if you travel a lap of omega s units along the j omega axis, there will be, for each lap, there will be a complete traversal. If you travel from omega equal to 0 downward, what will happen? You will travel in this direction because argument will be negative. As you travel downward, you will be traveling in this direction. And as you reach minus j omega s by 2, you will come here. All right. If you continue to travel downward, when you reach minus j omega s, what will happen? You will come back here. Therefore, I have written that this point is the image of several frequencies, omega equal to 0 to plus minus n omega s, where n can take on positive integer values. And that point will be the image of omega equal to plus minus n omega s by 2. All right. Omega equal to plus minus n omega s by 2, where n can take on these values of 1, 2, 3, etc. So this will be the image of omega s by 2. Then, sorry, there is a problem here. It will not be n omega s by 2. It will be n plus 1 omega s by 2. All right. N plus 1 omega s by 2. So there is a mistake here, because this will be the image of omega s by 2, 3 omega s by 2, 5 omega s by 2, 7 omega s by 2, like that. Similarly, it will also be the image of minus omega s by 2, minus 3 omega s by 2, minus 5 omega s by 2, like that. So this one will be within brackets n plus 1 omega s by 2. Do you understand? Or what will it be? N plus 1 ঠিক আছে? Or 2n plus 1? What will happen? If it is
2n plus 1, sir.
Huh?
2n plus 1, sir.
2n plus 1. So that the odd, it becomes the odd multiple. Within brackets, 2n plus 1 times omega s by 2. All right. So right here, within brackets, 2n plus 1, then omega s by 2.
And sir, right side এটা ওইটা তাহলে তো 2 এর ওটা তো পজিটিভ গুলো ইয়েগুলো পাওয়া যাবে।
হ্যাঁ,
সংখ্যা আপনার যেগুলো জোড় সংখ্যা সেইগুলো পাওয়া যাবে না, যেগুলো রাইট পার্টে আছে, রাইট হ্যান্ড পার্টে।
তাই তো। কি হয়েছে? ওমেগা s 0, omega s, twice omega s, thrice omega s, 4 omega s, 5 omega s, like that. এটা ঠিকই আছে। এটা তো ওমেগা s এর ইন্টিজার মাল্টিপলস গুলো থাকবে, তাই না? এখানে 2n plus 1 হবে। So both these points that I have shown in the z plane, they are the images. That point is the image of infinite number of frequencies along the j omega axis in the s plane. And this point is again the image of infinite number of frequencies here. All right. So this is a manifestation of the phenomenon of aliasing in the Z domain. Vechaka.
Sir,
Uh,
sir, please explain that part also. How can we relate any value in right side of the jet plane that will be the outside of the circular region? How can we relate that?
oh, that I'll discuss later. I am now concentrating on J omega axis.
Yes, sir. Yes, sir.
I am concentrating on, I have started with the J omega axis. All right.
Yes, sir.
Corresponding to any point on the right side of the S plane, you will have an image at the exterior of this unit circle, outside this unit circle. Where exactly the image is will be there, that is determined by both sigma and omega values of that point that you're considering. Now here, just see, I have written down the same thing. All right, this is omega tau, this angle. Now here, it appears to be very disturbing to the eye, but anyway, say we start from a certain frequency omega 1 along the j omega axis in the S plane. If I start from this j omega 1 and move upward, what will happen? I have arbitrarily considered that corresponding to omega 1, this is the value of, this is the image of omega 1 on the circumference of the unit circle centered at origin in the Z plane. So this argument is omega 1 tau. Is it clear? I have arbitrarily considered, just for the sake of illustration. So from omega 1, if you travel upward, what will happen? The angular frequency will increase. So from that point, you will be traveling here. Again, when you reach j omega s by 2, you will reach here. If you continue your journey from j omega s by 2 upward, then you will be traveling in this direction. And when you reach omega 1 plus omega s, all right, sorry, when you will reach omega s here, I have not shown it here. When you reach omega s here, you will come to this point. Again, from j omega s, if you travel upward, you will be traveling in this direction. And ultimately, when you reach the point j omega 1 plus omega s, you will come back to this point. You understand? Again, if you move up, you'll be moving in this direction along the circumference of the unit circle. And from here, you are traveling upward. So you will be traveling, you will be completing your journey in this direction. Again, when you reach omega equal to omega 1 plus twice omega s, you will make one complete traversal of this unit circle and come back here. It means that for every lap, wherever you start on the j omega axis, wherever you start on the j omega axis, for every lap of frequency omega s covered during your journey, the unit circle centered at origin, it will be having one complete traversal. You will be having one complete traversal along the unit circle centered at origin for every lap of omega s units that you travel along the j omega axis. You understand? So that point is the image of infinite number of frequencies given by j omega 1 plus n omega s, where n can take on values of 0, plus minus 1, plus minus 2, plus minus 3, etc. So in this way, for any point, these observations will be valid. So that is the important thing that we have noted, that for a journey along the j omega axis, wherever you start, when you move by omega s units, for every traversal of omega s units, you make a complete traversal of the unit circle and come back to the original point from where you have started along the circumference of unit circle. So this is, as I have already stated, a manifestation of the phenomenon of aliasing in the z plane. In the text, what I have narrated, what I have explained, that is not present in the text. So be careful to note it properly. You take your time, try to recapitulate whatever I have said and note it down. Hey, Ranu. Ranu? Do it. I do it. Have you drawn it?
Yes, sir, turns.
Now consider the mapping of left half of S plane into Z plane. For that purpose, we are dividing the S plane into infinite number of horizontal periodic strips. So infinite number of horizontal periodic strips, we have divided the S plane into such infinite number of horizontal strips of equal width along the j omega axis. Each strip extends from j into n minus half omega s to j into n plus half omega s. That means for n equal to 1, what will be the, where will it extend from? For n equal to 1, the strip corresponding to n equal to 1 extends from minus j omega s by 2 to plus j omega s by 2. Let me just show it. So that is the figure. All right, so this is for n equal to 0. So it extends from minus j omega s by 2 to plus j omega s by 2. All right. So this is the horizontal strip. It extends from sigma equal to minus infinity to sigma equal to plus infinity in the horizontal direction. Because it's for n equal to 0, we call it the primary strip. So what will be the expanse of the strip corresponding to n equal to 1 from j omega s by 2 to j3 omega s by 2? All right. Again, from sigma equal to minus infinity to sigma equal to plus infinity. So for n equal to 2, the horizontal strip will extend from j3 omega s by 2 to j5 omega s by 2, isn't it? So these strips corresponding to non-zero values of n can take on only integer values, and for non-zero values of n, all these strips, these are called complementary strips. The strip for n equal to -1 extends from minus j omega s by 2 to minus j3 omega s by 2 in this way. So that's why I've written here that each strip extends from j n minus half omega s to j n plus half omega s, n having these values. Our intention is to first divide the S-plane into such periodic strips and then start from the mapping of the left half of the primary strip onto the Z-plane. Only the primary strip. Have you written it?
No, sir. Once.
স্যার হয়নি।
Oh. বলে বলো।
আচ্ছা স্যার।
হয়েছে?
Yes, sir.
So this is the figure showing how the strips have been introduced. Introduced means how it has been, the S-plane has been divided. So there will be also strips for n equal to 2, n equal to 3, n equal to 4, n equal to 5. And in the downward direction for n equal to -2, n equal to -3, etc. Infinite number of such strips in the direction of j omega axis. n equal to 0 corresponds to the primary strip and others are called complementary strips. So as I have said, we will first consider the mapping of the left half of the primary strip in the S plane onto the Z plane. Now let's have a look here. So I am considering the left half of the primary strip that corresponds to n equal to 0. And say this is the, obviously this is the boundary of the left half of the primary strip. The primary strip will extend from minus j omega s by 2 to plus j omega s by 2. And in this direction, it will extend up to sigma equal to minus infinity. So this one will be minus infinity, not infinity, minus infinity. Now what we are doing, we are traveling along the boundary of this left half of the primary strip. We have started from A. So A is simply the origin. Although I have just shown it a little bit away, A is actually the origin. So from origin, we will travel up, reach the boundary of the left half of the primary strip, then travel left up to the point corresponding to sigma equal to minus infinity. As we reach there, we will come down. So we are traveling along the boundary. Then as we reach the point corresponding to minus j omega s by 2, there it's another boundary of the left half of the primary strip. So we'll come to the right and come back here ultimately. If that traversal is done, then what will be the contour that will be traversed in the Z plane? That is the question. That's what we want to find out. First, I have drawn the contour that will be traversed in the Z plane. We will start from here, and here there is an exaggerated view. All right. A magnified view of a type of notch that will be there. All right, then we will come back here. This is what I claim. Now I will substantiate my claim. This is the unit circle. Here there is a strange behavior. We'll see why such a notch is present. So we are traversing the boundary in the counterclockwise direction. Why do I say that this point A will map into that point A in the Z plane? Because same logic I have put before it a few minutes back, that it corresponds to the origin. So magnitude of Z will be 1, argument of Z will be 0. Therefore, this point will map onto that point, unit distance away from the origin of the unit circle in the Z plane.
The point A is at the origin.
Yes, yes. Because we are traversing along the boundary, so it has to be at the origin. Then we'll travel along the j omega axis up to j omega s by 2, travel leftward, then come down. As we reach sigma equal to minus infinity, we come down. Then on coming down, ultimately we reach minus j omega s by 2, that is another boundary of the left half. Then we travel right, reach the j omega axis, then travel up to end at the origin. If you have completed the drawing, I'll try to explain why we are traveling in that manner.
Done, sir.
At A, Z is 1 with argument 0. So that is the point here. As we are traveling upward, sigma is remaining constant, omega is changing. So magnitude of Z will remain constant at 1, and we will be traveling in this direction. So 1 angle omega tau is changing from 0, ultimately increasing from a value of 0, becoming more and more positive until you reach the point B. Point B corresponds to the frequency j omega s by 2 along the j omega axis. So at point B, what is the value of Z? 1 with argument pi radians. All right. So here, therefore, you reach B. So B here, the argument is 180 degree or pi radians. So it's on the unit circle, you may say. Why this notch is present?
But then
On reaching B,
B should
actually be here, but there is a notch. Why? I'll explain that. I have magnified the view of the notch. It's not such wide. So B is on the unit circle. Now, on reaching B, you have to travel leftward towards C. Traveling leftward means omega is remaining constant at omega s by 2. That means pi radians. All right. What is changing will be the magnitude of Z. What will happen to the magnitude of Z? Because sigma becomes more and more negative as you travel in this direction. What will happen to the magnitude of Z? It will decrease, isn't it? It's e to the power sigma tau. It will decrease progressively. And on reaching C, it will become 0 because sigma becomes minus infinity. This is minus infinity. So as you are traveling here from B to C, your argument is remaining same, pi radians, but your magnitude is shrinking as you travel from B to C. Magnitude is shrinking, it is reducing gradually, and ultimately as you reach C, the magnitude of Z, it becomes 0. E to the power sigma tau becomes 0. So magnitude of Z is 0. So C point is actually here at the origin. On reaching C point, as you are traveling down, what is changing? Sigma is remaining constant at minus infinity. So the magnitude of Z is remaining constant at 0 value. So what is changing is simply the frequency, omega. From a value of omega s by 2, the value of omega is gradually decreasing. Value of omega is gradually decreasing means the argument value is gradually decreasing. Ultimately, as you reach here, minus omega is by 2. D corresponds to minus omega is by 2. Omega equal to minus omega is by 2. So what will be the value of Z? Magnitude is 0. Argument is how much? Minus pi radians. So this is D. Magnitude is 0, but argument is minus pi radians. All right. As you travel from D to E, what will happen is that the value of sigma will become progressively less negative. Omega will be constant at minus omega is by 2. So argument will be constant at minus pi radians, but the magnitude will become, it will progressively increase because sigma is becoming more and more, less and less negative. So as you reach E, what will happen? The argument, it will remain same, minus pi radians. But from a value of 0 at D, because sigma is becoming less and less negative here, the magnitude is increasing. So that's why you are traveling in this direction. Magnitude is increasing. So when you reach A, sigma is 0. So magnitude will again be 1. So it will again come back to the unit circle, circumference of the unit circle. Next, as you travel from E to A, then sigma is constant at 0. So magnitude of Z will be 1, remain at 1. And here, what will happen to the argument? What will happen to the argument? The argument will gradually become less, and the omega value will gradually become less and less negative. Omega becoming less and less negative means you are traveling in this direction. From minus pi, it becomes less and less negative. So as you reach A again, the argument becomes 0, you are here. So this is the contour that is traversed. A notch is here, sharp notch is there. Often what is done is that instead of showing this as a notch, simply the unit circle is joined, the unit circle is constructed, and here two arrows are shown, one in this direction, another in that direction, two arrows in the opposite directions to represent that notch. All right. If that is the case, then on traversing the boundary, you are traveling along, the unit circle with a notch here. A sharp change in the magnitude, the magnitude will again come back to 1. So the interior of this left half of the primary strip, all these points, where will they map onto? The interior of this unit circle. The interior of this unit circle centered at origin in the Z plane. So if you consider the entire left half of the primary strip extending here up to sigma equal to minus infinity, the interior of the unit circle will be completely filled up. You understand? So for that, for filling up the interior of the unit circle completely, you don't require the entire left-hand side of the S-plane. Only the left-hand side of the primary strip, that is sufficient to fill up the entire interior. So any point here in the primary strip will map onto a point in the interior of the unit circle centered at origin in the Z plane. When the drawing is complete, I'll move further.
Sir, it means point B and E should coincide, and D and C should also coincide on U axis in Z plane.
Huh?
Sir, point B and E will coincide each other at a U axis.
D and E will not coincide. D is at origin. C is also at origin. Because there for C and D, the magnitude is 0. So essentially C and D, they are same point.
Yeah.
Completed drawing?
Yes, sir.
Yes, sir.
CC means counterclockwise. During traversal, Z varies in the following manner. So whatever I narrated, that is noted down here. Written it.
Yes, sir.
Just try to correlate whatever is written here with my narration. Same figure, need not draw it once more.
Done, sir. Done, sir. Done, sir.
Next is mapping of left halves of complementary strips. For that purpose, what I have done here is that I have considered a point. Just see here, SC is a point in the left half of the complementary strip with n equal to 1. First, let me explain. So if SC is this point in the strip corresponding to n equal to 1, so what's the expanse? What's the expanse of this primary strip? This is the primary strip. Minus j omega s by 2 to plus j omega s by 2. The strip corresponding to n equal to 1 extends from j omega s by 2 to j3 omega s by 2. And SC is a point in that strip. So what are the coordinates of SC, real and imaginary parts of SC? It's sigma c and plus j omega c. This is SC. Now, corresponding to any SC, any and every SC, you can find a point SP in this primary strip, which will have the same real part, but an imaginary part, such that the difference between j omega c and j omega p is omega s, j omega s. So this stretch is omega s, the width is omega s. So that is valid for a point present in every point present in this left half of the strip corresponding to n equal to 1. So SC is sigma c plus j omega c. Omega c is greater than omega s by 2, less than equal to 3 omega s by 2, because we are considering n equal to 1. Now that can be written as I have stated, sigma c plus j omega p. J omega p is this one, plus j omega s, where omega p equal to, where omega p is equal to, just 1 minute, there's a typing mistake here. Omega p is equal to omega c minus omega s. Omega p is equal to omega c minus omega s. All right. Omega c minus omega s. So that can be written as SP, sigma c plus j omega p. If you look at the figure, it is actually SP. So it's SP plus j omega s. If that is the case, now if you map SC onto Z plane and SP onto Z plane, what will be the difference? What will be the difference? What will be the Z corresponding to SC? ZC will be e to the power SC into tau. E to the power SC into tau means e to the power SP into tau, isn't it? Times e to the power j omega s into tau. All right? E to the power j omega s into tau, that is 1. So ZC and ZP, they are same. You understand? ZC and ZP, they are same. Therefore, in the strip n equal to 1, for every SC, we can find a point in the primary strip such that they will map onto the same point in the Z plane. And that will be inside the unit circle centered at origin in the Z plane. Now, if you generalize corresponding to a point in any one of the complementary strips, say I am considering the general case where n can take on values of plus minus 1, plus minus 2, etc. For any such point, SC in any one of the left half of the complementary strips, then SC can be expressed as SP plus Jn omega s. This n value will be different for different complementary strips. If that is the case, what will be the relation between the point to which SC maps into and the point to which SP maps into? I have written down here e to the power SP plus Jn omega s tau. So this one, that will be equal to 1. This is it because this is equal to 1. So e to the power SP tau equal to ZP. Same image, same image. So write down. Draw this figure and write down.
Done, sir.
Hmm.
স্যার স্যার লেখাটা হয়নি। ডান স্যার।
Written it.
Yes, sir. Done.
So this is the situation in the Z domain. Doesn't it show that the left half, you know that the left half of the primary strip will map onto the complete interior of the unit circle centered at origin in the Z plane. But doesn't it also show, from what we have observed in last few lines, doesn't it also show that left half of every complementary strip also, each and every complementary strip, its left half will map into the complete interior of the unit circle centered at origin in the Z plane. That is what we have observed. Because these observations that ZP and ZC and ZP, they are same. This is valid for every point in the left half of every complementary strip.
Sir,
Yes.
sir, it means, sir, it means SP and SC will coincide each other in the Z
Yes,
plane.
yes, yes,
Means
that
they,
is true. That's true. Same point.
sir, but in S plane both points are unique points.
Huh?
Sir, but when we see in the S plane, then both are different points, SP
Correct.
and SC.
That is the interesting part. So as they map into the Z plane, they become same point in the Z plane. If they mapped into different points, there would have been no meaning of these things that I'm narrating now.
Sir, then having only one point in Z plane, we can't recognize in which complementary strip it is.
That's true. That's true. That's true. So it also shows that correspondence between Z plane and S plane is not unique. Every point in the Z plane corresponds to infinite number of points in the S plane. But the reverse is not true. A point in the S plane corresponds to a single point in the Z plane. While a point in the Z plane, if you want to find out whose image that point in the Z plane represents, there will be no single answer. Infinite number of points can be there. So this is called the mapping of the left half of every complementary strip into the inside the unit circle in Z plane. That is referred to as aliasing of complementary strips into primary strip. So these are all, manifestations of the phenomenon of aliasing.
Answer.
Aliasing of complementary strips into primary strip. And that's how I have just illustrated it. All these left halves of all these strips, they map into the interior of this unit circle centered at origin in the Z plane. And the primary strip also maps into this interior. This shows the radius 1 unit, not properly drawn. Have you done it?
Yes, sir. Yes, sir.
So I have shown it for the left half of the S-plane in a similar manner. You can show for the right half of the S-plane that the right half of the primary strip will cover the entire exterior of the unit circle centered at origin in the Z-plane, and the right halves of the complementary strips will map onto the entire exterior. All right, of unit circle in the Z-plane. So wherever you are located in Z-plane, whether it is on the j omega, so whether it is on the circumference of the unit circle or inside the unit circle or outside the unit circle, if you have a point in the Z-plane and you are asked to find out the corresponding point in the S-plane, there can be no single answer. There are infinite number of possibilities. I have already pointed out the meaning and the implication of region of convergence of Z transform. Now, some more discussions are necessary regarding this region of convergence of Z transform. Region of convergence of Z transform. To start from the basic expression for bilateral Z transform. Say Z is equal to R times e to the power j omega. Obviously, R is magnitude of Z, and here the argument of Z is capital omega. Therefore, capital omega has to be in radians. All right. Capital omega has to be in radians. If it were small omega into tau, small omega would have been in radians per second. R, you know it's e to the power sigma tau. Now that summation representing the bilateral Z transform, you can split it up into two parts. What are those parts? Let us see. Now, first of all, the region of convergence of xz, I have redefined it. Set of all values of z for which the magnitude of the transform attains a finite value. That means xz exists. The values of z for which xz exists. So I have considered the magnitude of xz because this is the expression for xz that I have considered. It is the magnitude of this summation, and obvious inequality that we can write is less than equal to summation of the magnitude of xn r to the power minus n e to the power minus j omega n. Because the magnitude of e to the power minus j omega n is 1, this is the summation of n equal to minus infinity to plus infinity, magnitude of xn r to the power minus n. Therefore, I have split up the right hand side. Just see, magnitude of z is less than equal to this one. So I have split up the right hand side into two parts. First is the part for negative n, and the second part is for positive and zero values of n. All right. So if I change this, instead of minus infinity to plus infinity, I make it 1 to infinity. What change should I introduce here? Instead of xn, I should write x minus n. And instead of r to the power minus n, I must write r to the power n. This one I have just rewritten it in this form, xn divided by r to the power n. All right. Now, xz will converge in that region of z plane where both these summations converge. All right. So the condition for convergence of xz, the condition for magnitude of xz attaining a finite value is that region in the z plane or those values of z for which this summation as well as those summation, they are also finite. The common region where both of them are finite, or both of them converge. All right. Where will this first summation converge? It will converge for values of small r, that is small enough so that this x minus n r to the power n for n greater than 1 less than infinity, that x minus n r to the power n, that is absolutely summable. All right. That is the condition for convergence of this first term. What is the condition for convergence of the second term? It will converge for magnitude of r, value of r that are large enough. All right. That are large enough so that the product sequence is absolutely summable. So that's two different situations. Okay, you write down first, then I'll proceed.
Done, sir.
So a common region where both of the summations on the right hand side are finite, magnitude of xz will also be finite there. So what will be the nature of that common region? Magnitude of z has to be greater than a certain value r1 for the second summation to converge, and magnitude of z should be less than a certain value r2 for the first summation to converge. So in effect, for magnitude of xz to be finite, what will happen? Magnitude of z, it should be greater than r1, less than r2. That means magnitude of xz is finite over an annular region in the z plane, a ring-shaped region in the z plane, with inner radius r1 and outer radius r2. Just 1 minute. Oh, sorry, I have just done the reverse. R less than R2 are greater, R1 are greater than R2. Anyway, same thing.
Done, sir.
So that is for this summation. All right, R less than R1. And second sum will converge for values of the magnitude of Z large enough such that the product sequence is absolutely summable. That means R greater than R2. So first summation converges for R less than R1 and the second summation converges for R greater than R2. So what's the common region of convergence? Where both the summations will converge? A ring-shaped region such that R is greater than R2 less than R1. That means a ring-shaped region in the Z plane centered at origin whose inner radius is R2 and outer radius is R1. Remember that R2 can be 0 and R1 can also be infinite depending on the sequence. And for certain sequences, both of them, none is 0, none is 0, none is infinite. In a twist sense, it's ring-shaped region. What factor will govern whether it will be a ring-shaped region in the twist sense or it will be the exterior of a circle centered at origin in the Z plane, or it will be the interior of a circle centered at origin in the Z plane. We'll come to that. Not today, but have you written it?
Yes.
So this is the general way of representation of an ROC. If you come up with a sequence, so here essentially what is the R1 is greater than R2, isn't it? That is required. If you come up with a sequence for whose Z transform, you will find that R1 is less than R2. For those sequences, Z transform won't exist. You may come up with such sequences for which in the expression for the Z transform, you may find that R1 comes out as less than R2. So for those sequences, the Z transform won't exist because there is no common region where both of the summations will converge. Okay, let me stop today. I thought that I'll be giving you the example, but that will consume some time. So talk among yourselves and let me know when you can have the next class. Today is 19th and puja starts on 22nd or 23rd. So make up your mind and then tell me.
Sir, done, sir.
Done, sir.
Okay. All of you have completed writing.
Yes, sir.
Yes, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you very
Thank
much.
you, sir.
Thank you, sir.